Hello friends. Now, this is our last numerical. I hope you have gone through all the videos. You have studied each and every numerical. You have solved each and every numerical properly, neatly, cleanly. Now, before moving this question number 6, you should know all the values or all the ROCs that we have studied in properties of ROCs. As well as I hope you have gone through all the videos that we have recorded earlier. Now, the question number 6. Now, in this case, ROC is not mentioned. You have to find out which type of ROC will be there or maybe exist. And if there are two poles, then of course the ROC is always poles plus 1. That is 3. If we have a 3 poles, then of course the ROC is always pole plus 1. So if we have a 3 poles, then ROC is always 4. In this question, I have not mentioned any single ROC. We have to find out what are the different ROC can be placed or can be exist. And this is the new type of numerical that I'm going to solve at the end. So let's move on to problem number 6 first. Question number 6. Find inverse Laplace transform of x of s, and it is given s upon s plus 2 and s plus 3 the whole square. And what is mentioned? For all possible ROCs. Here ROC is not given, and in this numerical, what is given? Here we have a simple pole, multiple pole, and repeated pole. This question is based on all the three types. Simple pole means the order is 1. Now, multiple pole means what? Here we have more than one pole, and repeated pole means what? This order of one pole is twice or more than 2, which means the pole repeat itself at the same location. Now, we'll find out first of all partial fraction of this function, and then we'll move on to the ROCs. So let's go through the question. First of all, see what I'm going to do. My x of s was s upon s plus 2 and s plus 3 the whole square. Now look at here. How many poles are there? Here basically we have 3 poles. The first pole is s plus 2, the second pole is s plus 3 the whole square, and we are going to add a third most pole, which is the simple pole of s plus 3. So first of all, according to pole values, I'm going to place 3 different variables. Let's say a, b and c. First I will place the simple pole value, which is s plus 2. Then I'm going to place a second pole, s plus 3 the whole square, and the extra pole, adjacent pole, which is s plus 3, which is a simple pole value of s plus 3 the whole square. Now just multiply left hand side denominator on the right hand side, and then what I'm going to do, I'm going to substitute s different values of s to obtain the values of a, b and c. Now we have solved this type of numerical, which is a repeated pole. In this case, we have gone through two different ways solutions. The first solution was just substitute s equal to minus 3, and in third case s equals to 0. Now look at here. Here we have s plus 3 the whole square. It is a type of repeated pole. We have solved this numerical, such type of numericals in previous videos also. Now while solving this type of numerical, we have seen two different cases. You can obtain the partial fraction of this pole, or you can obtain the partial fraction of b and c in two ways. What was that? The first way is substitute s equals to minus 3 to obtain the value of b, and then put s equals to 0 to obtain the value of c. This was the first case, and the second case was, first of all, substitute equals to plus 2 and s equals to minus 3. And what was the second case? Substitute s equals to minus 2 and s equals to minus 3 to get the value of a and b, and then differentiate this whole x of s when it is multiplied with s plus 3 the whole square, and then after differentiation substitute or replace all the s by minus 3. This was the second case. You can choose any concept, or you can choose any case to find out the values of a, b, c. My choice is simply substitute s equals to minus 2, s equals to minus 3, and then to find out next variable, we'll substitute s equals to 0. You will get the correct result, so don't worry. Now I'll first of all multiply left hand side on right hand side, then we'll move on to substitution. So this is our equation number 2. Now what I'm going to do, I'm going to substitute s equals to -2 to find out value of A, then s equals to -3 to get the value of B, and s equals to 0 to substitute or to get the value of C. So just look at here what I'm going to do. Now I'm going to substitute s equals to -2 to find out value of A in equation number 2. What we will get, this s all the s replaced by -2. Look at here, if this 2s is replaced by -2, then whole term becomes 0. So B value and C value becomes 0. Only A value you can obtain through this equation. Look at here, -2 plus 3 is +1 and the square is also 1. So A into 1 is A and the answer is A equals to -2. Now we'll move on to s equals to -3. As this s is replaced with -3, on the left hand side we have -3, on the right hand side this s is replaced with -3 plus 3 and -3 becomes 0. So whole A term becomes 0. Similarly here also, as this s is become 0, so whole C term will also become 0. Only the B value you can achieve. On the left hand side we will get -3, on the right hand side what we will get, -3 plus 2, answer is -1. So we have minus B on right hand side. You can cancel these two minus signs, so what you will get, B equals to 3. Now for the third step, to find out C, what you will do, I'll substitute s equals to 0. What you will get, all these s replaced by 0. So on left hand side what you will get, 0. If this s is replaced by 0, then what will be there, 3 plus 0 becomes 3 and 3 square is 9. Now here this s is replaced by 0, so what you will get, 2b, here we have 9b, and both this s become 0. So in bracket we have 3 and 2, 3 2s are 6 and 6 into c is 6c. So here I'm going to write 9a. Now out of this a b c, this a value is known and b value is known. So shift this 9 and 2b on left hand side and then substitute the values of a b to find out or to get the value of c. So as I know that a value was -2 and b value which is calculated as a 3. Now just do the multiplication. -9 into -2, answer is 18, and 2 into 3 is 6. 18 minus 6 becomes 12, and here we have 6c. What you will get, if I divide this, then what you will get, c equal to 2. Substitute all the a b c value in our equation number 1. What you will get, the x of s equation becomes, this was our equation number 1, where this place is for A and next one is for B and third one is for C. Here the A value is -2, which is substituted, B is 3 and C was calculated as a 2. And I'm going to represent this is my equation number 3. Now what you can get this, here we have two poles. The first pole is s equals to -2 and third next pole is s equals to -3. I'll plot both the values on my S plane. Why I'm doing this, because in question the ROC value is not given. Means what, you have to obtain that ROC value from this graph. So here we have two poles. So maybe if your ROC is right handed sided, then the ROC will be greater than -2. This was our first ROC. If the ROC is left handed sided, then ROC is always exist on the left side of leftmost bit. Means what, the leftmost bit was -3, so your ROC is available on left hand side. So I'm going to write real part of S is less than the leftmost pole, which is -3, and the third is in between. In between means two sided. How to represent it? In between means the real part of S is greater than -3 but lesser than -2. These are the three ROCs, and we are going to find out the inverse Laplace transform of this x of s function on the basis of these three ROC. So just go through it once again to understand the concept how to find out the ROCs if it is not given in exam. And we know that how to find out inverse Laplace transform using a right-handed ROC, left-handed ROC, and a two-sided ROC. So I'm going to find out inverse Laplace transform, that is x of t, on the basis of all these properties or all these ROCs. So first of all, we have a two poles. The first one is -2 and second one was -3. So -2 on right side and the -3 is on left hand side. Now, according to that, we have calculated the three different types of ROC. The first ROC is real part of s is greater than -2. According to properties, ROC always placed on right hand side of rightmost pole. Here, the right-handed side pole is -2, so ROC is always exist on right-hand side of this rightmost pole because this ROC is a right-handed ROC. So I'm marking the first of all the straight line, and the ROC is available on right-hand side of this rightmost pole. This is the ROC of function. Now, according to property, if the ROC is right-handed sided, then all the poles will follow the same ROC, which means the inverse Laplace transform of 1 by s for each and every a, b, c term is always unit step. So, what is next step? Apply inverse Laplace transform on equation number 3. What you will get? The inverse Laplace transform of x of s is x of t. Now, next one is a constant. The a value was -2 and I'll take it outside. The next part is 1 upon s plus 2. 1 upon s plus 2. In that, s is delayed or shifted by plus 2, and the plus 2 means we have to multiply the opposite sign value of plus 2 with the t, which is present in the power of exponential term. So this is e to the power t. Here we have a t, and in the denominator of a we have s plus 2. So opposite value of plus 2 is -2. So multiply this -2 with the t. What you will get? -2t. And then what will be there? 1 by s, and 1 by s is nothing but unit step because the ROC is a right-handed sided. Now this was the first part. Now the third one is, next part is 3, b part. Now first of all, in denominator of b what we have? S plus 3 the whole square. Now as I told you, if we have this type of formula, or we have studied this t to the power n formula in mathematics, n factorial upon s raised to n plus 1. Now here, the whole bracket raised to we have a 2, which means n plus 1 value is 2. So n equals to 1 means what? This n value which is available on power of t is 1. So this t3 is multiplied by t, and then the next part is s plus 3 because we have solved the whole bracket square part. Now next part is s plus 3. S plus 3 means what? This s is shifted by 3, so multiply by t by the opposite sign value, which is e to the power t. This t is multiplied by the opposite sign value. The plus 3 we have in our solution will multiply this t by -3. Answer is -3t. And the 1 by s is nothing but unit step. Now the next part is for c. And the output for c was 2. And in that we have only 2 upon s plus 2 simple. S plus 2 means what? Again, we have s plus 2. This 2 gives us a shifting in frequency, then multiply the opposite sign value. Now in third case what we have? C value was 2, and in denominator of 2 we have s plus 3. Now here the frequency was shifted by 3, which means this t is again multiplied by opposite sign value, which is s3t into unit step u of t, and this is the ROC. This is the integration for ROC is greater than -2. Now we'll move on to next ROC, which is a left-handed sided, which means ROC is less than -3. Now the second ROC. real part of s is less than minus 3. Less than minus 3 means what? It is this ROC shows us a left-handed ROC, or this ROC you can say that gives us a left-handed sided ROC. Left-handed sided ROC means what? According to property number 8, if the ROC is left-handed ROC, then the ROC always plotted on the left-hand side of leftmost pole. Here the leftmost pole is minus 3, which means ROC is available on left hand side of this leftmost pole. So I will mark the region first. This is the range, and the ROC is available on left hand side. Left hand side means what? Over here. Then what will is the ROC for minus 2? If the ROC is left-handed sided, then all the poles will follow the same ROC, which means the ROC for minus 3 and minus 2 is also left-handed. What is meant by this? Which means all this s 1 by s, the inverse Laplace transform of all this 1 by s, 1 by s, 1 by s is represented by minus u of minus t. Now we'll write the inverse Laplace transform, or we'll apply the inverse Laplace transform on this equation. This was our equation number 3, which is written in previous pages. Inverse Laplace transform of x of s is x of t. Now, as this minus 2 is constant, I will take it minus 2 common. And then again we have s plus 2. S plus 2 means what? First of all, I will multiply this t value by opposite sign value of plus 2, which is minus 2t. And then as this ROC is a left-handed sided ROC, then inverse Laplace transform of 1 by s is minus u of minus t. So minus u and this minus sign becomes plus. And what I'm going to do? U of minus t. The next part is 3 plus 3, but we know that this s is also replaced by minus u of minus t. So I'll place first of all minus sign, because plus into minus become again minus, so I'm not going to write once again. Now I have written first of all a constant part 3, then as we have a square, then what we have done in last part, the factorial part, t to the power n is n factorial upon s raised to n plus 1. Here the whole power is 2, n plus 1, I'm going to equate this n plus 1 with the 2, so n is 2. In this case, what we have? S plus 3 the whole square we have. So n plus 1 is equals to 2. Here we have s plus 3 the whole square. Now equate this or compare this form with t to the power n factorial. We have studied one formula. T to the power n is nothing but n factorial upon s raised to n plus 1. Here the power raised to we have a 2, and in formula we have s raised to n plus 1. So compare this 2 with n plus 1. What you will get? N equals to 1. That's why I have written t to the power 1. Now next part is s is delayed by 3, so multiply e to the power t by opposite sign. This we have plus 3, so multiply this t with the minus 3, and then as I told you, inverse Laplace transform 1 by s is minus u of minus t, because the ROC is left-handed sided. Now already I have taken a minus sign outside, so what is remaining? U of minus t. Now again here also we have a plus sign. I'm going to replace this plus sign by minus, because this ROC is left-handed, which means the inverse Laplace transform of 1 by s is again minus u of minus t. So minus sign will change this plus sign value to minus, and I'm going to write first of all this constant part, and if we remove these two, then the result of both the poles are same. So no need to write this t for this solution or to find out the inverse Laplace of this. Only next part is important, but I will tell you how to write the answer. S plus 3, which means s is delayed by 3, so multiply this t value by opposite sign value, which is a minus 3t, and as I told you earlier, the ROC is left-handed sided, so 1 by s inverse Laplace is u of minus t, and the minus sign was already multiplied outside, and this is the solution for left-handed sided ROC. Now the third part is remaining, which is a two-sided ROC. So let's see the next step. Now the third ROC, this is the last. Now you can say that here the ROC is greater than minus 3, means what? The ROC for minus 3 pole is a right-handed sided. Right-handed sided means what? For minus 3 or minus 3 pole, ROC is right-handed. Right-handed means I will mark the ROC on the right-hand side of this pole. Now in this case, A real part of S is less than -2, which means ROC is for -2 pole is left-handed. Left-handed means first of all I'll mark the region, and then ROC is available on left-hand side of -2. So draw the parallel strips to represent the ROC. Now look at this. This is ROC number 2 or type of ROC number 2, a two-sided ROC. Now in this case the unit step value changes. That is for +3, for this type of pole the unit step value is always u of t, but for -2 the ROC is left-handed sided, the unit step value is replaced by -u of -t. Now I'll show you how to find out the inverse Laplace transform of this question. So applying inverse Laplace transform on this equation, what we will get? X of s Laplace transform is inverse x of t. Then look at here we have -2, so I will write -2 constant part as it is first, but next part is s plus 2. So as I told you earlier, we have to multiply this t by -2 and then 1 by s. The pole produces left-handed sided ROC, then 1 by s inverse Laplace transform is -u of -t. -u, so minus sign I will take it outside, this minus minus become plus, so we have 2 e to the power -2t u of -t. The next part is this 2. So first of all I'll write the constant part 3 and then s plus 3 the whole square. So according to the t to the power n formula, I'm going to write this, we have only t, and this next part is s is shifted by 3, so we'll multiply this t by -3t, and the ROC for -3 pole is right-handed sided, which means 1 by s is nothing but unit step. Then we'll move on to third part, which is a 2. Here we have s plus 3, so multiply this t by -3t and then 1 by s inverse. As the pole produces right-handed side ROC, so 1 by s is nothing but unit step. And this is the ROC of the last function, that is a two-sided function. Now that's all for now, but to understand this ROC concept you have to solve number of numericals, number of various numericals, so that you will get the idea how to obtain the inverse Laplace transform if the numerical is based on ROC. But now what is next? Next part is a next type of inverse Laplace transform. So thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.